Hello and welcome to this Python tutorial. So in the previous sections we already introduced two nonlinear regression models, the polynomial regression model and the SVR regression model. So far polynomial regression seemed to be the best one, and today in this tutorial we are going to build the decision tree regression model and see how it will handle the problem. Okay, so let's quickly take care of the basics. We'll go to File Explorer here to set the right folder as working directory. So here we need to go to regression, and we are now in the decision tree regression section. So let's go on it, make sure that we have the position salary CSV file. And if that's the case, let's click on this little button here to set this folder as working directory. And now let's start to build our decision tree regression model. So we'll go to our regression template and take everything from here to here and paste it here. Now let's change the basics. Here I'm going to call that decision tree regression. Alright, let's copy that and let's paste it here. Alright, and now the basics is done. We are ready to change. The only thing that we do need to change, this part here where we create our regressor. So let's remove this comment and let's now create our regressor. So as usual, it's going to be very simple. It's going to take 3 lines and we're going to do exactly like before. We're first going to import a class from a certain library, and then we're going to create an object of this class which will be a regressor object, our decision tree regressor. And then we will use the fit method on this regressor object to fit our regressor to our dataset. And then it'll be ready. We will just need to execute the sections one by one and we will get to the final results. So let's do it. Let's start with the first step here, which is to import the right class for the job. So actually this class is from the sklearn.tree library. All right. And from this library, we are going to import the decision tree regressor. So careful to use the capital here, capital D, capital T, and capital R. That's because it's a class, and this is the name of the class. So as usual, a very intuitive name. All right, so we imported the class, and now let's create an object of this class, which is our regressor object. So we're going to call it regressor as usual, and then equal. And then we're going to call the class that we just imported because this is actually an object of this class. Here we go. And of course we add some parentheses because we need to specify some arguments. So let's have a look at these arguments. Let's press Command or Control plus I to inspect the decision tree regressor class. And what do we have here? Okay, so we have the criterion, and the default criterion is MSE, mean squared error. So we're taking the square difference between the prediction and the real result, and we're taking the sum of these differences to measure the error. So this is a very good and common criterion, and this is the one we're going to use for our decision tree regressor object. And since it's the default here, we don't have to do anything, we're fine. And then we have some other parameters like splitter or max features. That's if you want to take a more advanced approach of how you build your decision tree. So we will not focus on that right now. We will leave it to the default parameters. Actually, the default parameter for splitter is, as you can see, best. So I guess we're fine with that. And so we will just actually, you see there are a lot of parameters. So we're not going to input some values one by one, but we are going to specify a random state value because we all want to get the same result. Okay, so let's do it. Let's input here random state equals, so we can pick whatever number we want. I usually input 0 or 42. Well, let's put 0 here. Okay, great. And now we'll all get the same result. So we are on the same page. So that was the second step, creating the regressor object from the decision tree regressor class. And now the final step is to fit this regressor object to our dataset. And as usual, we're taking our regressor object like this, then a dot because we're calling a method, and then we're taking the fit method here, right? And now we need to add some parentheses because it has some arguments, and as you can see, those arguments are x and y. X is our matrix of features, and y is our dependent variable vector. And that fits our regressor object to our data set because our data set is composed of x, the matrix of features, and y, the dependent variable vector. Okay, great. And now we are actually ready to execute the sections one by one and get the final result. So let's do this. So remember, for SVR we had to apply feature scaling. This was a trap. Let's see if it's still a trap here, and let's see if we need to apply it. We will first try not to execute the whole thing without applying feature scaling, and we'll see what happens. Okay, so let's execute the section one by one. Let's import the libraries first. Done. Let's import the data set and select the right columns. All right, done. Now, no need to split the data set into the training set and the test set because we have a very small data set. No need to apply feature scaling maybe. And now we're finally getting to the section where we create our decision tree regression. So let's select this section and execute to really create it. Here we go, create it properly, and all the default parameters were selected. Okay, so far so good. And now let's either predict the previous salary of this employee that had a 6.5 level in its previous company, or visualize the results. Well, let's keep the best for the end and let's see what is our prediction for this previous salary. So remember, we're negotiating with a future potential employee that is about to be hired. We're negotiating its offer. This person is saying that its previous salary was 160K and he's asking for more. And based on the information we have on the table of salaries of the previous company, and knowing the information that this employee had a level 6.5, we're trying to predict its previous salary. So this person is saying its previous salary was 160K. Let's see what our model says. All right, so the prediction is made. Now let's see what it is. We need to go to Variable Explorer, and it's 150K. Wow, for the first time, we are getting a prediction below the mentioned salary. Well, for polynomial regression, it was very slightly below. It was 158K, and now we get 10K less than what this person was saying as its previous salary. But I guess that's quite close, and that's still a good prediction. Even if it's not on the good side of the negotiation, I guess that's fine. So let's check to see what happens on the plot, where we can see the decision tree regression results. So we're going to execute this section and find out about how the decision tree regression model handled the dataset and managed to fit its model to our dataset. So let's do this, and here's the plot. Wow, okay, so I'm going to enlarge this. And now the first word I have to say here is trap or red flag. Right now, we're just in front of a new trap. According to what Kirill explained in the intuition tutorial, do you think that's the real shape of a decision tree regression model? Well, because you know what Kirill explained is the algorithm of decision tree regression is that by considering the entropy and the information gain, it's splitting the independent variables into several intervals. So in the intuition tutorial, you had two independent variables. So the different intervals formed some rectangles in which you took the average of the dependent variable values. But here, since we are in one dimension, that means that the algorithm will only take intervals here of the independent variable. For example, that should be one interval, and here it looks like it's a second one, and here it's the third one, and here a fourth one. Okay, but as you understood in the intuition tutorial, it's taking the average in each interval. So if it's taking the average, how do you want to have this straight line here that is not horizontal? Because you know what the decision tree regression is doing is that in each interval, it's calculating the average of the dependent variable salaries, and therefore for all the levels contained in this interval, the value of the prediction should be a constant equal to this average of the dependent variable in this interval. And here, as we can see, it's not a constant. You know, the prediction here is not the same as the prediction here. So either it's considering an infinity of intervals with different constants in each of those infinite intervals, or either we have a problem here. Of course, it's not the first option. Of course, the decision tree regression is not considering an infinity of intervals between this level and this level. So it's definitely the second option. So now do you see where the problem comes from? Well, the answer is in our regression template, because what we observe here is only due to the resolution we picked to plot these decision tree regression results. Because we're actually plotting the predictions for each of the 10 levels incremented by 1. That means that here, it's only plotting the predictions of the 10 salaries corresponding to the 10 levels, and then it's joining the predictions by a straight line here because it had no predictions to plot in this interval here of the independent variable level. And the fact that it's a problem for this new nonlinear regression model, the decision tree model, is due to a very specific reason. For the previous nonlinear regression models, we could use the code that generated this plot because the models were actually continuous. So, for example, in the polynomial regression model, well, between these prediction and these prediction, well, it was actually almost a straight line here. However, right now we're facing a new kind of regression model. Remember, the first kind of regression model we studied was the linear regression model. Then the second kind of regression model we saw was the nonlinear regression model. And now we're facing a new kind of regression model. It's the nonlinear and non-continuous regression model. Indeed, all the previous regression models that we saw, whether they were linear or not linear, they were all continuous. But here, the decision tree regression model is not continuous. And this is the first non-continuous machine learning model we are seeing together. And so do you know what is the best way to visualize a non-continuous regression model? Well, as I was telling you, the answer, the solution for this is in our regression template. So let's have a look. And actually we need to take the code section that visualize the regression model results in higher resolution. So let's take this and let's actually go back to our decision tree regression file and replace this code here, because this is totally not appropriate for a decision tree regression model because it's a non-continuous model. And so we need to replace this code by the same, but for the high resolution. And now let's check it out. The model is actually ready. We can actually replace that by decision tree regression. And now let's check it out, and you will see what the real decision tree regression model looks like in 1D. So let's do it. Let's select all this and execute. And here it is. That's what it looks like. And actually, since it's a non-continuous model, we should even have some strictly vertical line here, to represent better the non-continuity. And to do this, we just need to increase the resolution. So I'm going to put 0.01, and you'll see that we'll get the real representation of the decision tree regression results. So let's do it. Here it is, now almost vertical, and that's a clear representation of the decision tree regression model. So now let's zoom on it, and now it makes much more sense. Because as Kirill explained, based on the entropy and the information gain, it splits the whole range of your independent variable into different intervals. So here we can clearly see where the intervals are. And as Kirill explained in the intuition tutorial, the decision tree regression model is considering the average of the dependent variable values in each of the intervals. So for example, if we consider this interval here, the average of the salaries in this interval, well, that's very simple. It's actually 150,000. And so for each of the level between 5.5 and 6.5, the salaries will be predicted to be $150,000. So we already know what our model will predict for our 6.5 level here. It's going to predict 150K. So speaking of this prediction, and now that we get the decision tree regression graphic results very well, let's actually check that the previous salary of this employee that had a 6.5 level in its previous company is really 150K. Let's check it out. Let's select this line and execute. And here it is, 150,000. So now I just want to say two things to conclude. The decision tree regression model is not an interesting model in 1D, but it can be a very interesting and very powerful model in more dimensions. So that's why you can use this code here for your data set. You have the code here that builds the model and this one here that makes the prediction, but then you won't be able to use this code because you'll have probably a lot of independent variables and therefore a lot of dimensions. But you know, Kirill gave you the explanation in 2D. I'm giving you the explanation of 1D so that now in your mind, you can perfectly represent in your head the decision tree regression and how it works. And now I would like to end this tutorial by an enigma. In the next section you will see random forest. And a random forest is actually really simple. It's just a team of several decision trees. So, knowing that this is the result of one tree, what do you think we'll get with a team of 10 trees? Or even 100 trees? Or 500 trees? The first question is, do you think we'll get this shape of some stairs here? And the second question is, do you think we'll get a much more accurate prediction, like a prediction that is getting very close to the 160K that is supposed to be the real salary? So these are the two questions. I will let you think about that, and I look forward to giving you the solution in the next section.